Hi, it's Mr. Adams here, a maths teacher with over 20 years experience, and I'm looking at solving housing affordability. In this video, I'm looking at impossible events and why they seem to happen so regularly in finance. I'll often hear, sometimes on the news, sometimes from an individual, that what we're seeing is a once in a lifetime event. And yet, I'm only 45 and I feel like I've lived through dozens of these events, especially in finance. This graph is from a textbook that I use. Now, this is called normal data because it fits in a lot of circumstances. Now, there is a rule associated. It's called the 68, 95, 99.7% rule. And what it says is that 68% of the data lies within one standard deviation of the mean, 95% within two, 99.7% within three standard deviations. Now here's a graph of A.V. Jennings looking at the daily change as a percentage for 10 years. And what we find is that the data mostly fits this normal data, that those rules that I have said before mostly fit. So when we do the calculations, we find that there's a mean of 0.01%. So it's just going up by a little bit each day. The standard deviation is 2.6%, and then 68% of the data we expect to be between negative 2.61 and 2.63. We expect the vast majority of data, 99.7%, to lie between negative 7.86% and 7.88%. So the data seems to mostly fit, except that we've got these unusually large values and unusually small values. So what I've got here is the calculations for 4, 5, 6, 7 and 8 standard deviations above and below the mean. And then I've counted how often the daily price change is below or above that. Now I know this is a lot of numbers, just bear with me and I'll explain what they mean in context. So when something's 4 standard deviations above or below the mean, that should happen twice in a lifetime or every 43 years. And yet here it's happened 17 times across 10 years. So this is happening 36 more times than what we expect. When we look at events that are 5 standard deviations above or below the mean, they should happen only once in recorded history. However, here we've got 11 times that it's happened. So it's happened 5,000 times more than what we would have expected. Once we move into the territory of 6 standard deviation, we're talking about things that should never happen. Like we've got here that it should happen theoretically twice in recorded history, and yet it's happened 8 times over the course of 10 years. Moving to 7 standard deviations above and below the mean should again never happen, and yet we've got 4 instances here. I'd like to thank Wikipedia here for putting things into context. So 8 standard deviations should never happen, like as they specify here, is once in every 2.2 trillion years. So never in the history of the universe. So this is something that should never ever happen in any circumstance. Except on the 28th of the 11th, 2024, the share price moved by 87.88%. So on the previous slide, if it was above 20% thereabouts, it'd be 8 standard deviations above the mean, and here it is like 4 times that amount. We have no way of actually working out how unlikely this actually is. So A.V. Jennings is a small company, so there could be an argument that they don't really fit in with the typical Australian company. But let's have a refresher. 5 standard deviations above and below the mean, they had a total of 11. On the other hand, CSL, one of Australia's largest companies, had 10 incidences that were 5 standard deviations above or below the mean, which should never happen. So what's going on with these impossible events happening so often rather than not at all? One possibility is that when people see an unusual event, they will react in a way to make that event more unusual. So when a stock is rising, they'll jump on, but also do the reverse, jump off when it's going the other way. The other possibility is the theory of normal data is actually just wrong. So normal data was created to describe a pattern of height in the human population. It was soon discovered that it works mainly in multiple different circumstances, but real data is repeatedly found not to actually fully fit with it. The tallest person ever, Robert Wardlow, grew to 272 centimetres. Now, the mean height of men is around 178.4 centimetres and a standard deviation of 7.6 centimetres. Now, that gives him a z-score of 12.6. So that means he was 12.6 standard deviations above the mean. And we know pretty well anything above 4 or 5 is pretty well impossible. So 8 standard deviations above the mean is that is close to 1 quadrillion. 12 standard deviations above the mean is a probability that I don't know. Wikipedia at the time of recording didn't actually go up that far because it's just considered it to be impossible. So someone of Robert Wardlow's height should never have existed, and yet he did. So apologies for a huge digression. The question is, what does all this have to do with house prices? I looked at real house prices across the OECD from the year 2000 to 2021, where the data stopped. Now, when I use the word real, what I'm doing is talking about inflation being taken out of it. So the data is comparable. I looked at house price changes as a percentage from the previous year. I then calculated the mean was 2.82% and the standard deviation was 6.86%. I then did similar calculations to what I did with AVGenics. So for one standard deviation, we had a lower limit of -0.4 and an upper limit of 9.7. What we found was there were 80 values below that and 68 above that. What was predicted was 112.5 both ways. So this is roughly in line with what we'd expect. When it came to 2 standard deviations above and below the mean, we got roughly in line again with what we'd expect. Once we got the 3 standard deviations, this is where the data starts to look pretty weird. So we're expecting about 1 above and below 3 standard deviations of the mean, and yet we've got 5 below and 6 above. According to the theory, there should have been no incidences of the data being 4 standard deviations above or below the mean, based on the data that we had, and yet I found 3 below and 3 above. And if we extend the data more, we find that there's an incidence where there was some data that was more than 6 standard deviations below the mean and more than 6 standard deviations above the mean. And this is like, it just should never happen, and yet it has. So we've got this difference between experimental and theoretical probability. Theoretically, on 0.15% of years will result in a 17.8% house price fall, but experimental probability suggests that it's actually much higher at 0.71%. But more than this, the reality is there's this conditional element. So if house prices being higher, it makes it more likely that there'll be a sudden decline. So in any given year, if house prices being high, it's going to be a much higher chance of decline than 0.71%. Could be 2, could be 3, I actually don't know. Other things to note from the OECD data is we have these high years followed by low years. So for instance, in 2006, Estonia's house price increased by 41.8% and then 12% the following year. The next 2 years, it dropped by 16.1% and 36.6%. Between 2002 and 2007, Spain averaged 11.9% growth. This was then followed by an average decline of 8.4% over the next 6 years. For the UK, over the same period as Spain, it was 9.5% growth, followed by a 3.2% decline. Germany averaged a 1.5% decline from 2001 to 2010. That was then followed by 4.2% growth over the next 10 years. Colombia averaged a 4.28% decline from 2001 to 2003, and then that was followed by a 6.6% increase over the next 7 years, which included the years of the GFC. So in conclusion, normal data in the real world has data points that are theoretically impossible but happen surprisingly regularly. Higher house price growth are an indication that there'll be lower house prices in the future. The higher the house price growth, the more it increases its chances of a sudden decline. So sudden declines creates negative equity, and that in turn creates instability in financial markets. In my 5th video of this series, I talk all about negative equity, about what the issues are and some of the solutions. The most stable trajectory is to keep house prices low. So there's basically 0% chance of a dramatic fall, because what we find is when there's an extended period of no or low house price growth, it's not followed by a dramatic fall. In fact, it's more likely to dramatically increase. So if we want to avoid falls, we got to keep things low for a long period of time. Banks want house prices to be higher because it creates more profit, because the higher the house prices, the higher the interest, the more that you end up paying to the banks. But this is not offset by the risk entailed. Thanks for watching. Please subscribe and hit the like button. Please leave a review and a comment. I'm not a financial advisor. I'm a mathematics teacher with a passion for teaching financial literacy. Please read the disclaimer.